Hi, I'm Minho, and for my final project, I chose to do it on hotel booking demands. First, I'll go over the table of contents. In this presentation, I'll first go over why I chose this topic and then introduce you to the data set. Next, I'll go over what I did in my project, followed by the analysis, classifiers, and methods I've used. I'll then go over the results and finally give recommendations on which classifiers, methods, and techniques I believe would work best for this data set. First off, I'd like to go over the motivation of choosing this dataset. I personally am a big traveler and I was wondered how the travel industry worked behind the scenes. So when I heard about this project, I just wanted to choose this dataset. When traveling, there are three big things to consider: figuring out what to do, what to eat, and finally where to book as accommodation. Accommodation may be the most important out of the three when it comes to traveling, which is why I chose to look deeper into this. From a business perspective, this is very important as it gives insight to current and potential hotel owners on what kind of factors they should be on the lookout in order to maximize their profits by avoiding cancellations. With this motivation data set, I'll try to answer questions like, are individual bookings more likely to cancel their reservations later on, etc. I'll ultimately try to make predictions using the given tools from class to answer if a guest, based on their preferences and circumstances, will cancel their reservation or not. Before we get into the actual data, I want to give you a brief overview of the data itself. The dataset we'll be working with is the hotel booking demand dataset that originates from the data article Hotel Booking Demand Datasets by Nuno Antonio, Ana del Almeida, and Luis Nunez, which was published in 2019. Later in 2020, Thomas Mock and Tone Bychek cleaned the dataset during the hashtag Tidy Tuesday. Information regarding personal identification has been removed from the dataset initially. This dataset initially started with 32 different features. There are a total of 15 categorical features and 17 numerical features. Features are not limited to the hotel type, the meal plan the guest booked, the country of origin of the guest, and whether or not the guest canceled their reservation. You can find a table about all the features and the descriptions in the report. With this in mind, let's move on to how I prepare my data. Before doing any serious work with the data, I believe that starting by filling and replacing missing data would be the best approach. I have listed all the steps I took during this process of making and cleaning up the data so that it would be fully utilized. The cleanup was done precisely in this order because there are some steps that are dependent on the previous one. For example, changing the values for the company column had to be done in order as I matched the company column value to their market segment and distribution channel column first, and then replaced non-null values, and finally set the leftover values as individual. This also goes for the agent column as well. One thing I do want to mention here is the process of binning countries together. There were a total of 178 individual countries that were in the dataset. I believe this would bring in too much variance in the dataset, so I binned each country to the respective continents. By doing this, I was able to bring down the 178 individual categories down to 8. About the other processes, I performed cleaning such as getting rid of duplicate rows and correcting data types to the correct types. For the processes mentioned here, you can find their implementation details in the report. For dimensionality reduction, a couple of features were combined together. The children, babies, and adult features were combined into a total number column. Also, the number of nights stayed on a weekday and the number of nights stayed on a weekend were combined together to a total nights column. For the feature selection, various observations and techniques were used to select which features were irrelevant to the model and ultimately be removed. Most importantly, the target feature was selected as the canceled column, as the main goal of the project is to see what kind of factors lead to guests canceling their bookings. Luckily, the dataset came with this column, so it was a no-brainer choosing the target feature. Before we go into the next phase, I want to go over some brief observations I have made about the dataset. I have made several plots to help me understand the dataset through visualization. Among the plots, I have here two of them that represent the distribution of the type of hotels and the cancellation rate by hotel type. If you take a look at the left plot, we can see here that guests tend to make more bookings at city hotels over resort hotels. And for the plot on the right, it shows that the percentage of cancellations is also higher for city hotels. This raised an eyebrow as it seems like there are factors that are particularly significant to city hotels compared to resort hotels that want to make guests cancel their bookings. Like this plot, all of my plots are focused on the cause of cancellation. There are plot pairs where one describes the number or percentage of a guest characteristic, while the other describes the cancellation rate of the guests with that specific characteristic. There are more plots included in my final report that make similar findings as the one I just mentioned. In the next slide, I will go over the regression analysis I performed for this project. For phase 2, I've used multiple analysis techniques to evaluate and better fit my model to get them ready to make predictions. The techniques I've used are not limited to the t-test, association analysis, f-test, confidence interval analysis, stepwise regression analysis, and collinearity analysis. A lot of the techniques were done using the OLS method provided in Python. By looking at the p-values and the confidence intervals, adjustments to the dataset were made. Most of the analysis was performed with the in-canceled feature being at stake, as the purpose was to figure out how relevant and useful other features are in affecting guests canceling reservations. The collinearity analysis was done using the variance inflation factor (VIF) method. After I performed these regression analysis, I went ahead and applied the dataset to different machine learning classifiers, which I will talk about in the next slide. For phase 3, I used different types of machine learning classifiers and got performance results for each classifier. The classifiers I ran are the following: decision tree, logistic regression, KNN, SVM, naive Bayes, random forest, and neural network in this respective order. The decision tree was handled three ways: no pruning, pre-pruning, and post-pruning. The KNN was handled two ways: no specific end neighbors and a specific end neighbors number. The KNN with no specific end numbers was performed first, and then the KNN with a specific end neighbors number was performed. The value for the specific end neighbor numbers was found by the process of performing grid search. The random forest was handled in three ways, using Gini, entropy, and log loss. After running the 7 different machine learning classifiers, they were compared on their individual performance results. In order to evaluate the performance of the machine learning classifiers I ran in the previous section, I went ahead and looked into the most frequently used evaluators when it comes to comparing machine learning classifier performances. I was able to narrow down to the 7 different methods which I have listed on the slide. The confusion matrix, accuracy score, specificity, and ROC curve were obtained using the proper imports from scalar metric and yellow brick classifier. Whatever visualization that was possible for each evaluator was obtained and included in the final term project report. Through the classifier report, I was able to obtain the precision, recall, also known as sensitivity, and the F1 score for each classifier. The next slide will go over the statistics obtained for each classifier in accordance with the mentioned methods. Here we have a table of all the performance statistics that were obtained to make thorough comparisons between the different machine learning classifiers. Each column represents one of the machine learning classifiers that was run, and each row has a performance evaluator score. Each row represents one of the evaluation methods I mentioned in the previous slide. However, I was not able to fit in the ROC curve in the table. Those for each classifier can be found in the final project report. Let's start by comparing the accuracy of each classifier, as it is often considered the most significant indicator of whether or not a classifier is good at making predictions. Looking at the accuracy row, we can see that the random forest classifier has the highest accuracy, while the naive Bayes classifier has the lowest accuracy. This means that this version of the dataset worked best with the random forest classifier in terms of accuracy. For precision, we can see that the neural network and random forest classifier were both the highest at 81%. The KNN classifier had the lowest at 68%. For recall, again, we can see that the neural network and random forest classifier were both the highest at 82%. This time, the naive Bayes classifier had the lowest recall, 63%. For the F1 score, again, we can see that the neural network and random forest classifier were both the highest at 81%. The F1 score was the lowest for the SVM classifier, 61%. Lastly, we had the specificity. Surprisingly enough, the SVM had the highest specificity at 99.8%, almost close to 100. The naive Bayes specificity was a staggering 57.5%. This is the lowest score across the board for any evaluator and classifier. By these results, we can tell that there isn't one classifier that outperforms the rest of the classifiers. However, the random forest classifier was equal to or slightly better in most metrics except for the specificity. And as it had the highest accuracy, I came to the conclusion that the random forest classifier worked best in making predictions using this particular dataset. From the previous slide, we found that the random forest classifier works the best for this dataset in making predictions with the listed performance statistics. However, as you saw earlier, there are some classifiers that perform nearly similar to this classifier. The neural network had an accuracy just 0.2% shy of the random forest classifier. There are two classifiers, the logistic regression and the SVM, that outperformed the random forest classifier in terms of specificity. Both performed 1% and a staggering 7% better respectively compared to the random forest classifier. Going back to the accuracy score, as the neural network is just a little bit shy of what the random forest classifier outputted, this could mean that with the right amount of tuning to either the dataset or classifier, the neural network classifier might outperform the random forest classifier. As mentioned in the previous slide, I think it's important to understand that the random forest classifier shows the highest accuracy with this particular modified dataset in the particular way tuned by classifiers. Therefore, we shouldn't think of this as the end of finding the best classifier. Instead, we should think about how and what we can do to improve the performance of the random forest classifier along with the other one. So what could we actually do to bring up the performance of the classifiers? There are numerous ways of improving classifier performances, but I believe these four would be the most effective. The first one is reducing the dimensionality of the dataset even more. Even though I have reduced the number of features in my data pre-processing step, there could have been features I have misinterpreted and either overvalued its significance. The second way is collecting more data. Having more data entries may help in building a more accurate model. This does not necessarily mean increasing the dimensionality. In fact, we probably want to avoid increasing the dimensionality. The third method is algorithm tuning. As we know, there are multiple ways of tuning classifiers. Just for the random forest classifier, you can set different tuning settings, such as the different number of trees in the forest, maximum number of features, maximum number of leaves, etc. Through a different combination of tuning parameters, we may be able to increase our classifier performances. And finally, we could use ensemble learning, such as bagging and boosting. I was not informed enough about ensemble learning, so I cannot apply it to this final project. However, from the research I have done, I believe that if it were applied, they would have improved the performance of our model. And with that, I conclude my presentation on hotel booking demand. All details can be found in my final project report. All the references in making these slides are also included in it. Thank you very much.